I'm Anil Kumar. Welcome to my series on Rolle's theorem application. Here is a brilliant question, multiple choice question for you. Find the value of k if root of derivative for the polynomial function f of x equals to x minus k whole cube times x minus 8 whole square is at x equals to 6.4. Four options are given to you. You can always pause the video, answer the question, and then look into my suggestions. Now, there are a couple of ways to solve this question. One is definitely we are given the function f of x equals to x minus k whole cube times x minus 8 whole square, right? We can from here find the derivative f dash x, which will be 3 times x minus k whole square times x minus 8 whole square, plus we are applying the product rule, right? So we have here, now we'll multiply by 2. So let me write first this function, which is x minus k whole cube. Derivative of this will be 2 times x minus 8, right? Now, since we are saying find the value of k if the root of the derivative for the polynomial function is at 6.4, that really means that the at 6.4, if I substitute 6.4 here, I get 0. So I have to write this as 0 equals to all this, correct? 3 times x minus k whole square times x minus 8 whole square plus 2 times x minus k whole cube times x minus 8, it is x minus 8, right? So we need to solve this equation. Definitely you can solve for k, right? So from here you can solve for k and get one of these answers. So I'll call this as our method number 1. Now method number 2 is what we learned in the Rolle's theorem. One of the related questions I want to share with you now is this one, right? So what we did was that we took a general equation where f of x was x minus a to the power of m times x minus b to the power of n, and we say that for this particular function, it's a polynomial function, value at a and b is 0, therefore a root exists in between for the derivative, and we derive the formula, which is right there. It is like a division of line segment, right? So that's the formula. I'll provide you the link for this. Now the idea here is you can apply this section formula here and get your answer. Perfect. So go through the link and understand the concept behind, and then you can use method number 2. So the idea here is that since we have all this given to us, we know that the value of x for which we are getting this particular solution is given by the formula, which is 2 times k plus 3 times 8 divided by 2 plus 3, or you can write 3 plus 2. And the value of x is given to us. The value of x is given to us as 6.4. You get the idea, right? Now we can solve for k. So this is our second method. So we say 2k is equal to 6.4 times 5 minus, so we'll solve for this, right? Minus 24, correct? So we get the value of k as, you can now multiply this and divide by 2. So 6 times 4 is 20, 0, 2, and that is 32, minus 24 divided by this number 2, right? So now 32 minus this is 8, and 8 divided by 2 is 4. So you do all this calculation to get your answer as 4. So this is a much simpler method. Concept is Rolle's theorem. Perfect. So what we have here basically in the given situation is that on our line the zeros are at a point which is k, and the value is 8, correct? So the function is continuous. So we do have a root in between somewhere here, which is given to us at c, right? So we are saying that somewhere here, which is 6.4, the derivative is 0, right? That derivative is 0, right? So that's what it is. So it's a degree 5 equation. So if you kind of sketch this function, here it will bounce back, correct? And then what we're trying to say here is that it will be kind of going like this. So the graph will be, and here it will be going, right? So that is your cubic root, correct? So what we are trying to say here is that the horizontal tangent will be at 6.4. That's what we are trying to say. Is that okay? And you need to find the value of k. So you can use this section formula, which is in general given as m times a plus n times b over m plus n, right? And get the solution as we have shown you in the example and apply it here to find the solution. So that really helps. So I'd like you to go through that video and understand how to solve using Rolle's theorem. That will definitely help. Or just use section formula. Now you know. Or just use section formula as we've done here to find the solution. I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best. Question here is, find the value of x at which the root of the derivative for the polynomial function f of x equals to x minus a to the power of m times x minus b to the power of n exists. Now, this question will remind you of Rolle's theorem. We have a polynomial function, right? So we know one thing, that is all polynomials are continuous, right? So polynomial function means continuous, right? Now, we are given the equation as x minus a to the power of n. So let me call this function f of x as equal to x minus a to the power of m times x minus b to the power of n. So we also note here that the value of the function at a and b is 0. So we also note that the value of the function at a is 0 and the value of the function at b is also 0. Correct? That gives you the idea that we have 2 points with same value on the function. So f of a is equal to f of b and both are equal to 0, right? So we have 2 points where the value is same and the polynomial function is continuous. It is differentiable also, and it is polynomials are differentiable. In their domain, right? So that satisfies the 3 conditions for a function where the Rolle's theorem can be applied, correct? So that means there exists x equals to c, where c belongs to the open interval from a to b, right? Where f dash c is equal to 0. Now look at the question. Find the value of x at which the root of the derivative. Now when we say root of the derivative means f dash x exists, right? So find the value of x at which the root of the derivative exists. Now when we say root means that derivative should be equal to 0. So the key word here, root of the derivative. So whatever the derivative function is, it has to be 0 somewhere in between, and that will be treated as its root. You get the idea. So this value f dash equals to 0 is the root of the derivative, right? F dash x. F dash x is the derivative. So at C, it is 0. Do you understand the concept, right? So that's the huge concept with which we are going to work, and we are actually going to derive a very good relation here which can be applied in many multiple choice questions. So we know there exists, let's figure out what is this point, right? So we're given the polynomial function f of x equals to x minus a to the power of m times x minus b to the power of n. So what is the derivative of this function? Well, the derivative will use the product rule, m times x minus a to the power of m minus 1 times x minus b to the power of n plus, we'll have derivative of this now, it's n times x minus a to the power of m times x minus b to the power of n minus 1, correct? So that becomes the product rule, and from here we could actually factor out terms which are x minus a to the power of m minus 1 and also x minus b to the power of n minus 1, right? We can factor these out. So what you get here is m times x minus b, and you get plus n times x minus a, correct? So that's what you get after factoring. Now we know that there exists a point C where we have a root of this derivative, right? So at x equals to c, there has to be, which is within a and b, there has to be a root, right? So we need to find what is that point. So for that, we can equate this to 0. So we now know that 0 is equal to, this is finding root of derivative, right? Clear? So we'll equate this to 0 equals to all this. So 0 is equals to x minus a to the power of m minus 1, correct? X minus b to the power of n minus 1. We are looking for something in between a and b, right? Okay, not a and b. So these cannot be 0. These are 0 at a and b, but something inside should be 0, right? So m times x minus b plus n times x minus a should be 0, right? So that implies, now this cannot be 0 between the interval a and b, right? So, but inside portion should be 0. So that means m times x minus b plus n times x minus a is equal to 0, correct? Now, from here, we can solve for x, correct? So let's solve for x. We'll just multiply, let's do it on this side. So we'll just multiply and open. So we get mx minus mb plus nx minus na equals to 0. Taking x terms together, x, we get m plus n. And here, so we took these two terms, right? And we are left with minus of mb plus na, correct, equals to 0. So from here, x is equal to, taking this to the right, we get mb plus na divided by m plus n. So that is the value of x at which the derivative is 0, right? So for us, f dash c equals to 0, where c is basically equal to this, right? So x equals to c, which we are saying is this value, which is m times b plus n times a over m plus n. Now this formula reminds you of division of line segment, right? Line segment in the ratio of m is to n, right? So in the ratio of m is to n, correct? So that is how you actually get, so that means this point is in the interval a to b, right? So that gives you the idea that these are the 2 points. So when we say, let me write b and a. If I write a and b, in that case, the ratio A, it will be n is to m, right? So if I write like this, it will be n is to m. So either way, we could switch it over, correct? So when I'm drawing like this, then that is the ratio. So that is a point here, and this point is C, where the derivative will be 0. Is that point clear? Perfect. So I'd like you to understand the whole concept, and then we'll take up a multiple choice question to answer, and we'll verify using derivatives.